This is a continuation of the synchronization video. Um, right, so let's take a look at the methods which give up locks when threads execute them. Well, the only method that does it is wait. When a thread executes this method, it actually gives up the lock. And these are the methods. When a thread executes these methods, they actually keep the locks. And these are the classes in which they're implemented. So join, sleep, and yield are implemented in the thread class, whereas wait and notify belong to the object class. Local variables need no protection because every thread gets a separate copy of them. So protection is actually needed only for the instance members as well as the class data members or the class members. Now let's consider two cases in which if I have a synchronized instance method, if I try to use a static data member in it, it screws up things. So is the case when I try to use static members within instance members. So it's both conditions: using static data members within instance methods and using instance members within static methods. Now, case one is the one in which we try to access non-static data members in synchronized static methods. Now, say if I have this class with instance member IM and static member SM. Now, I have a run method. Now, if thread is T1, then I want to execute the static method by passing in the instance of T1. Else if thread is T2, then I want to invoke this method, which is instance method, right, which is a synchronized method. And here I have a synchronized static method. Now what happens is, say within the synchronized static method, I'm trying to access well, using this instance, which is nothing but R1. If I'm trying to do this obj.im, which is valid, right? Now T1, which is executing this method, synchronized method, acquires the class lock, whereas T2 here acquires R1's lock, right? So because T1 is executing a static method, it acquires the class lock, and T2, because it's executing an instance method, it acquires R1's lock. So both are valid entries. So T1 would be executing this and T2 would be executing this, right? Now T1 would be trying to modify the instance member using in the static method, whereas T2 would be trying to access or trying to modify the same instance member, because if you notice, this has been passed into the static method. Now this refers to R1, and R1 is implicit in the instance method. Now, so using explicit reference, which is this, which refers to R1, and using an implicit reference of R1, you're trying to access the same data member, right? So this is R1's IM and this is R1's IM, which would be modified by T1, T2, and there is what is that called? A race condition. Now both T1 and T2 can access IM simultaneously, so that would be a race condition, despite of the fact that each method is synchronized. So you have a static synchronized method which is trying to access an instance member, and you have an instance synchronized instance method which is trying to access the same, which is trying to access an instance member. So in that case, you would mess up things. Now case 2 is the one in which you access static members in non-static methods, non-static synchronized methods. So consider this example in which you have a static member, and the run is executed by T1 and T2 for different instances of this class, R1 and R2. Now, so T1 now T1 would be invoking this method, and T2 would be invoking this method, right? Uh, would be invoking the synchronized instance method. Now T1 gets the log of R1 and T2 gets a log of R2, which is perfectly valid, but they both come into the method and try to access a common static member, because static members are class members. It's common to R1 and R2, which is what the thread is trying to do, what the threads are trying to do. So T1 would be trying to access or modify the class member, and T2 would be at the same time trying to access the class member, which is not valid because it's not synchronized. Now T1 modifies static member, and so does T2, so that's the problem. So to make a class thread safe, methods methods that access changeable fields must be synchronized, and not just that, but the access to static fields should be within synchronized static methods, and the access to non-static fields should be within synchronized non-static methods. This is really important. You could have a combination, but it's not discussed. It wasn't discussed in the book, so I'm not really sure what the solution would be. But for now, just remember these 2 points. Now, thread safe classes. So classes which are carefully synchronized to protect its data. Now, string buffer and string builder are identical classes, but string buffer with identical methods, but the methods of string buffer are synchronized, whereas the methods in string builder are not synchronized. So, which implies that string buffer class is much more safer to be used in multi-threaded environments. But what should be kept in mind is that thread safe classes affects performance, because the lock should be acquired and released, so which adds additional set of instructions to take care of all this. Now let's take a look at deadlocks and threading. Well, this is the sample code. Now say if T1 executes, now say if this is the sample code, you have run method, and if thread is T1 you read, if thread is T2 you write. Now T1 acquires lock of resource A because T1 is trying to read, right? So T1 reads, and it acquires resource A's log, and say this immediately T2 acquires log of resource B, which is now T2 is executing this piece of code, and it acquires resource B. Now T1 has resource A's log and T2 has resource B's log. Now if say in the third step T1 would try to acquire the log of resource B, but it cannot because it's being taken by resource T2. Similarly, T2 would try to get the lock of resource A, but it cannot because its resource A's lock is being held by T1. Now T1 would wait indefinitely for T2 to release the lock, and T2 would indefinitely wait for T1 to release resource A's lock, right? So T1 would be, or rather, T1 would be blocked on resource B, that is resource so resource B has a lock pool, and T1 would be waiting in that, and resource A has a lock pool, and T2 would be waiting in that forever. So T2 would be waiting for T1 to release A, and T1 would be waiting for T2 to release B. It's not going to happen. Now, well, what happens if a thread cannot get a lock. Well, okay, imagine this situation in which all these threads are trying to get the lock of R1 to enter the synchronized instance method. Now T1 gets R1's lock, and it goes in to execute it, and T2, T3, and T4 wait. So how do they wait? So every instance, which is in this case R1, has a lock pool. Now T2, T3, T4 wait in the lock pool of R1, and after T1 releases the lock on R1, any one of the threads in the pool is picked up. There could be situations where you are using a thread safe class in which every method is synchronized, but you need so that only guarantees atomic execution of each method of this class. So method 1 executes atomically and method X executes atomically, but it doesn't guarantee that if you have these two methods one after the other, these two methods would be atomically executed together. So if you want these two methods to be atomically executed, you need to have them in a method, and you need to have them in a synchronized method, so both of these would be atomically executed. So this is the solution for that. Thank you.